Hello, all. Good morning, ladies and gentlemen. Welcome to my channel, Krupa's Wireless Wisdom City. Here we discuss about 3GPP, 4G, 5G, and beyond all the technologies. We cover technical critics, interview questions, in-depth knowledge, and some of the very crucial points in understanding the specification to the implementations. Coming to today's discussions, today we shall be covering now my knowledge ID is 38.211, which is the specification 3GPP chapter 5.1 and the constellation distance. Today's discussion is about constellation distance. The keywords are digital modulation, constellation distance, and the critical part is bit toggle. How much bit toggle we do and versus the constellations. This is one of the very important things to understand how the 3GPP has proposed for the constellation points. For we today we'll take the example of KPSK and discuss in details. Okay. So coming to the question, what are the distances between constellation point in KPSK? Give implication of choosing such constellation points positions. In fact, 3GPP has very tactically given constellation points for a greater reason. So we'll cover today. All right. So in KPSK, I have every constellation points. All of us know it is 2 to the power 2. So that means 4 points, and each constellation point represent 2 bits. It's 00, 01, or 10, or 11. Okay, so let's get into the more details. So this is your 3GPP 38.211 5.1 chapter. If you refer, and they have told what would be my constellation points if you are taking 2 bits as input. If you look at b of 2I and b of 2I plus 1, and your I start from 0. If you take it in this case to b of 0 here and bits of 0 and this bit of 1. So let's take 2 bits here, right? 0, 0. So if you apply 0 here and here 0, then you are getting the constellation point plus 1 plus j, right? That means 0, 0 is getting mapped to my first constellation, right? Then if you take 0, 1, if you notice here 1 minus 2, this is 0, this is 0, and 1 is here. Look at here, this is minus 1 plus 1 minus j, right? Where does it point to? It points to 4th quadrant, right? And similar way 1 0, if you calculate, it's coming to minus 1 plus j, and that would go to your 2nd quadrant, right? And my 1 1, if you apply to the same equation, if I apply 1 1, then this would take you to 3rd quadrant, right? So looks little awkward, and so it looks like as if we didn't intend to be placed this way, but there is a reason why the 3GPP has proposed to place the constellation points in this very cryptic way. All right, so let's cover the next aspect of it. So as I said, the first quadrant will be 0 0, and my second quadrant is 1 0, right? And if you take it, the third quadrant is 1 1, and my fourth quadrant is 0 1. Now if you notice, every 1 bit change you are doing, let's say you do here to here or here to here or here to here, every 1 bit changes you are doing, if you go by the distance that it covers, it is 2 into 1 by root 2, right? It's very clear, right? There is no doubt about it, because 0.707 is 1 by root 2. So the distance, let's say take an example. So if you take distance, it will be 2 into 1 by root 2. That means 1 bit toggle, I am causing root 2 distance to cover. All right. Now take another case where I'll go for this another ink color so that it doesn't change the understanding. So if I take here, let's say I changing diagonally, take this point 112 and 11.2 0 point. That means my both the bits are changing, right? So this distance is covered is 2, right? How you can easily calculate, right? This distance plus this distance, and whereas if you use these distances, this will be 1 and 1 plus 1, this will be 2. So the diagonal distance, right? The diagonal distance that it is covering whenever there is a 2-bit toggle. Let me clear the screen. So the diagonal distance whenever there is change of 2 bits, 0 0, let's say 1 1. So the distance is this much distance is your 1. Again, at this half distance is another 1. So 1 plus 1 is equal to 2, right? So the diagonal distance we are covering whenever 2-bit toggle is there, it is 2. Whereas when in case of 1-bit toggle, it is 1.41. Now the point is, when the 3GPP has designed, there is a very key aspect of it, why they designed this way. And that point is, if you look at this greater distance, of 2-bit toggles contribute to a better resilience against noise. This is your very critical things to understand. So if any noise comes and tries to toggle my constellation points, he has to traverse longer distance if it is expecting to change both the bits. The interpretation of both the bits it wanted to change, then it has to traverse much longer distance, unlike if it has to change just only one bit. That is the crux of why 3GPP has proposed this kind of equations, so that my constellation distances are having a very critical or a very important properties. And that property is, when there is a channel, or you call it noise or interference, any of the channels trying to impair your constellation points, and it want to change 2 bits. Out of 2 bits, it has to traverse through a longer distance. And that is how it is protecting the 2-bit toggling is not happening so easily, unlike 1-bit toggle. Okay, so this is the critical point which I want to discuss in today's session. I hope you enjoyed the critics about 3GPP decision of choosing such constellation points and the equations. If you like my video, kindly subscribe to my channel, as well as put like buttons to it, so that it motivates me, and I would keep coming with such critical videos, so that it enhance your knowledge and you can face interviews or apply this knowledge to your work situations. Thank you very much for joining me. Bye bye.